These questions are similar to questions 3, 4, and 5 on the quiz. They're not identical, but very similar. Solve these equations showing each step. First, what it means to solve an equation is to figure out what the variable is equal to. That's all that means. So our answer at the end should be something like k is equal to some number. Now a lot of you could figure out some of these in your head, but I was really looking for whether you could show your steps clearly using inverse operations, not just guess and check. So for instance, in this problem, k minus 10 is equal to 7. I wanted to see one of two methods, either using your inverse operations on both sides of the equation or treating it like a mystery number method. So I'm going to show each of those. The algebraic way to solve this is to think, what happened to k? Well, I subtracted 10 from it. The inverse operation of subtracting 10 is adding 10. My goal is to get k by itself, so I want to get rid of this minus 10. To do that, I can add 10 over here. But this is an equation. That means that this side has to stay balanced with this side. And if I add 10 over here, I have to add it over here as well. So k minus 10 plus 10 is just k, because that's 0. So I have k is equal to 7 plus 10 is 17. So that is my answer. K is equal to 17. If you want to use the mystery number method, that's also acceptable. We start with the mystery number k. We subtracted 10 from it and got 7. So going in reverse, we can add 10 to 7 and get 17 that way. Both of these methods are perfectly acceptable. What I don't want to see is like stuff like this. That's not really sensible. Okay, second problem. We're going to do the same sort of method, algebraic and then mystery number. So two things happened to m. First, it got multiplied by 4. Second, it got added to 2. So I need to go in reverse and apply inverse operations. So first, I need to deal with the 2. I want to get rid of this 2 because I want m to be by itself. We need to isolate the variable. So I'm going to do the inverse of adding 2, which is subtracting 2. And what I do on one side, I have to do to the other side. So I get 4m is equal to 8. And now I want m by itself. I need to do the inverse of multiplication, which is division by 4. What I do to one side, I have to do to the other side to keep it equal. M equals 2. If you want to use the mystery number method, let me quick show you what that would look like. We have our mystery number m. First we multiplied it by 4, then we added 2 to the result and we got 10. So going backwards, we're going to apply inverse operations. We're going to subtract 2. 10 minus 2 is 8. And then we're going to divide by 4. 8 divided by 4 is 2. the same steps as we used algebraically, just written in a slightly different format. And finally this one. Oops. Let's think about what happened to our variable n. First, it got divided by 8. This was a big problem for people. They thought this was multiplication or subtraction. This is division, it's a fraction. And second, it got added to 16, or 16 got added to that result. And we ended up with 96. So we're going to go backwards using our inverse operations. So to undo adding 16, I want to subtract 16. What I do to one side, I must do to the other side. 96 minus 16 is 80, and that's equal to n over 8. Because this part's gone. 16 minus 16 is 0. All right, we've dealt with that. Now we have to undo the division by 8. Again, we want n by itself. So to undo division, I have to multiply both sides by 8. And it's tempting to divide this by 8 because it is divisible by 8, but you need to pay attention to what the inverse operation actually is. And in this case, it's multiplication. 80 times 8 is 640. That is equal to n. N equals 640. So that is solving equations. I'll show you the mystery number method with this as well. Same steps. So we started with our mystery number n. We divided it by 8 to get some other number. And then we added 16 to get 96. Now we subtract 16. Let me use my red for inverse operations. Subtract 16 to get 80. Instead of dividing by 8, we have to multiply 8. 80 times 8 is 640.